Hello.
We're back with another past paper.
Yep.
Don't we spoil you?
Absolutely. We're doing June of 2008 because we're imaginative and we're going up until we run out of big papers.
Yep, it's core 1. I just put core up there. Core,
Yeah.
look at that. Question
Apples.
1.
Yes. So, here it is.
Let's get on with it. So, it's a horrible question to start with.
That's what they like to do, sometimes not very often, but occasionally, to scare you a bit. So if you are struggling with a question at the end of the paper, skip it and come back to it. It's a good way to sort of do it.
Yep. So what it's done is it's given us a line and a curve again, which is normally the last question in a paper.
It is often, but it means it must be something else now. Maybe a circles question will be the end. So it gives us, we have these two things, and it says sketch on the same axis the line and the curve C, showing the values of intercepts on the x and y axis. So to do this, first we need to know what the graphs look like, and then we need to know what their intersects look like.
Yes.
So to start with, we don't want this in brackets. Oh, but actually it is really helpful in brackets, because this tells us where it intersects the x-axis.
Yes, and if we expand it out as well, we can also find out the y-intercept and whether it's a positive or negative x squared, which we can already see it's going to be positive.
Yeah, so we're going to have x squared, not
Plus 2x.
plus 2x minus 6. Sorry. It's just making up numbers now.
So from this, as Triv said, we can find it goes through the points.
Minus 3 and positive 1.
1. And it goes through the y-axis at minus 3.
So these are all points you should put on. So remember, where it goes through the y-axis doesn't have to be its vertex, that'll probably be a bit lower.
And because this is only 1 unit this way and it's 3 units this way, this isn't going to be the lowest point. It's going to dip and then go back up through there.
Yeah.
Something like that.
Something
it's going to
like
be
that.
positive. We know that because of this x squared.
Then we can draw on our line.
We can indeed. We know the y-intercept of that one because that's what this constant at the end represents.
Yeah, it's going to go
-1.
through minus 1. And we also, if we make y equals 0, we know that it's going to go through the x-axis at a third.
Yep.
Which is less friendly, but we can put that on anyway. And then we'll just draw the line
It's
between.
going to go through about there. It's a third. It's going to go up pretty sharpish.
Yeah,
like
because
that.
we know it's got a gradient of 3, so it'll be up quite straight.
So we can see roughly there's going to be 2 points of intersection with these things.
Yeah, and that's a good way to start sort of thinking about what you're doing. So now we've drawn the first bit, we now need to know when they intersect, and to do that we can simultaneously equate them.
Yep.
If y equals each of them...
Way over here.
Yeah. So, if y equals each of them, they must equal both.
Yep. So we can make 3x minus 1 equal to, we can just go straight to this step and make it equal to the thing we've already expanded, which Triv has done, x squared plus 2x minus 3.
Yes. And then if we put more round, we want to keep it on this side, but I'll move it over here.
You want a positive x squared, which means you're taking this 3x over that way, so it's going to be minus x, because you've already got a 2x, and this minus 1 over that way to make minus 2, because it will be a plus, equals 0, which is right, 2 marks.
Oh, as well, do you have to, as part A, do you have to say where it showing the values? Oh no.
No, it just says so that it satisfies that equation, which we did.
Oh, okay.
The hard part is if you struggled on A, you probably didn't expand it, so that's why this was probably worth 2 marks, just in case you can't do A.
Okay, I was skipping ahead to C on part A, sorry about that.
Yep.
C is find the coordinates of the intersection. You do that by finding out what these are.
You did indeed.
So you can factorise this, I think. Can you?
Yep, minus 2 plus 1. X minus 2 and x plus 1 would expand to get this. You're just factorising them when they're equated.
So it says ask for the coordinates? Yes. So this will be at x equals 2.
The other one is x equals minus 1, but that's not a coordinate.
No, we need our y part, and to get our y part, we need to put it back into one of the equations.
Any will do. This one looks the simplest to me.
It does, so if you put 2 into that, we'll have 6 minus 1, which is 5.
So one coordinate would be 2, 5. And the other coordinate, you substitute the minus 1 into here, so it's minus 3, minus 1 is minus 4. So minus 1, minus 4.
Yeah.
And there you go. Things likely to trip up on is not reading that it says coordinates and just finding the x values. It's quite common.
Yeah.
You might not expand it correctly and you might not think about what the graph looks like properly.
But if you just do all those, alright, then you should be okay.
So that was question 1. It started quite evil. I don't know if it's going to get any better, but we'll see you at question 2.
Yeah.